Hi, my name is Stuart Lynch. In this video, we're going to take our first deep dive into Apple's new Foundation Models framework. It's the first of several videos in this series. I'm going to walk you through in this video the basics from embedding the on-device model with just 3 lines of Swift code to handling errors and device availability checks. I'm going to do a brief overview of the Foundation Models framework at the start of this video. So if you're really just interested in getting the code and explanations for any one of the different sections, you can use the chapter markers in the description to jump to that section. But it might be worthwhile listening. I do have a starter project for this video, and I encourage you to download it from the link in the description. There are 2 branches, and if you want to work along with me, download the starter project branch. And you can either clone the repository or download the zipped archive. I do recommend that you do work along with me, but if you would prefer, you can also download the completed source code from the completed branch. It's totally up to you. Now, before we get started, let's take a quick look at the overall structure of the project as it is at this point. I use this technique in a lot of my video projects so that you can install on a device and access any one of the views that we're going to be working on. I have an enum called My Tabs that represents each of the views that I'm going to work on. And since it conforms to the view protocol, each one of the enum cases in itself is a view. And I can use the raw value of the enum to represent the title of each view. The Start tab is where the app launches into, and I just loop through each of the enum cases to present a tab in each of the views. I inject a navigation manager into the environment so that I can track the selected tab and use the raw value of the enum as the title. In the preview, so that the correct title shows up in the preview, I create a previewable nav manager and set the correct selected tab when the preview appears. Pretty simple. Now, the Foundations Model API was introduced this year at WWDC, and as you'll learn in this series of videos, it is extremely powerful. Way too powerful to cover in a single video. So this is going to be a series that will build on the previous one. So I encourage you to follow along in sequence as I work along through this API. The Foundations Model Framework is Apple's developer toolkit for tapping into their on-device large language model, the same one that powers Apple Intelligence, with native Swift support, privacy by design, and without ongoing API costs. As far as key capabilities, there is on-device Swift-friendly integration. You can embed Apple's 3 billion parameter language model into your app with literally as few as 3 lines of Swift code. And it runs entirely on device. So there's no latency, no user data leaving the phone, no cloud fees. And that is where we are going to start in this video and continue in the next one. There's guided generation, and that's where it gets interesting for Swift devs. You can define Swift types, either structs or enums, annotated with generable. And the framework ensures that your model outputs match those types, meaning you can get a strongly typed structured response without messy parsing. And we'll be covering this a little later in the series of videos. With tool calling, you define custom Swift tool conforming objects. The model can intelligently invoke these tools when needed, enabling dynamic functionality like calling APIs or fetching data right from natural language prompts. This too will be coming later. And then with Apple Intelligence and the Foundation Models framework, there are built-in guardrails that reduce the risk of harmful output. And you'll see that in this video and how you can deal with that. Now, before you get too excited, there are some limitations to keep in mind. There is this 3 billion parameter max. And this is tiny compared to ChatGPT or Claude, where there are hundreds of billions. A parameter is a neural network, which is basically a learned weight value that influences how the model processes inputs and generates outputs. And you can think of a parameter as knobs the model adjusts during training to capture patterns in language. It's good for summarization, classification, guided generation, or structured tasks. But it's not great for deep reasoning, creative writing, or multi-hop problem solving. And there is, by nature of it being on device, limited training data scope. It isn't a universal knowledge base. So don't expect it to handle obscure trivia, cutting-edge research, or broad world knowledge. It works best when you provide context or constrain outputs with the generable types. And this is perhaps the most important limitation to keep in mind, at least for now. It runs only on Apple Silicon A-series chips with enough neural engine capacity. So on an iPhone, that means an iPhone 15 Pro or later. And for you as developers, you have to be on an Apple Silicon Map, and you must be running Xcode 26 or later, and have macOS 26 installed on your machine. So expect slower inference compared to server-side models, especially for long prompts. And energy consumption matters on mobile. Apple's optimized for efficiency, not raw power. Now, I'd be remiss before I start if I didn't mention at this time Mark Moykins of Big Mountain Studios' new AI Mastery in SwiftUI book. I had the pleasure of doing some early reviews on this book as it was in development, and as I expected, it's a fantastic resource. I highly recommend it, and I have left a link in the description. A lot of my planning and ideas for examples for this series of videos is based on what I gained from reading Mark's book, so Mark's early work on this topic is greatly appreciated. Now, right at the start, I said that you can embed Apple's foundation model into your app with literally as few as 3 lines of Swift code. So let's see that in action. I'm going to use this services folder to contain a lot of extra code, like this navigation manager. And it's here that I want to create a new playground file for quick testing. So in that folder, I'm going to create a new file, and I'm going to call it Foundation Models for Playground. I'm going to import the Playgrounds framework. And then I'm going to use the Playgrounds macro to create a new playground closure for your code. Next, I'm going to import Foundations Model Framework. And now for those 3 lines of code. Well, the first thing that you need to do is to create an instance of the LanguageModelSession class. Next, you'll need to create a prompt and pass that into the session's respond method. And this can be a simple string like, "What are the colors of the rainbow?" Now, this method response is asynchronous and can fail. So we'll need to embed that in a task and use a try await the result, which is determined by calling the session's respond method, passing in that prompt. 3 lines of code, a session, a prompt, and a method call to respond to the prompt. In less than 2 seconds, we see that the playground preview displays a response from the Foundations model framework. And there are 2 properties to that response. There's the prompt itself that you passed in, and the content, which is the answer to the prompt. Well, we can capture the content by letting the entire response be what we get back. And then we can print out just the content portion. Now you'll notice that each time you run the playground with an Option Command P, the response might be slightly different, and the length of time it takes to respond also changes. There are no guarantees that you'll get the same response every time. If you're enjoying this video, please give it a thumbs up and leave me a comment. And be sure to subscribe to my channel and enable notifications. You can also subscribe to my newsletter that comes out on Wednesdays 2 or 3 times a month. I'll leave a link in the description. The newsletter will tell you about my current and future videos, along with other things that I discover along my coding and personal journey that I think you might find interesting. If you enjoy my content and you want to support my work, you can buy me a coffee. A link's in the description. And if you become a $5 a month monthly member, you can get access to all of my videos, sometimes up to a month before they're released on YouTube. So now that we know how to get a response, let's look at how we can incorporate that into a SwiftUI view. So we're just going to create a question and answer view. So let's create state properties for our prompt and reply, which will be the response's content. Both of these are going to have to be strings. Next, I'm going to replace the content in the VStack with a text field using question as the title. And the text will be bound to the prompt property. I'd like to make the text field style rounded border. Below the text field, I'm going to add a button with the title Answer. And I'll leave the action empty for now. I'll set the button style to bordered prominent. And I'm going to make it disabled if the prompt is empty. And below that, I'm going to create a scroll view. And inside the scroll view, I'm going to add a text view that will display the reply. Pretty simple. Now, in order to create a session and submit the prompt, we're going to need to import foundation models. With that, then, we can go to our action and create that session object as that language model session. Then we can create a task that will let us get the response be the result of trying and waiting the result of calling the session's response method with that prompt as the input. And you can see that it can be a string or a prompt object. More on that prompt object in the next video. The reply then is set to the response content. This, though, could be reduced to changing the response to actually assigning the content of the response directly to the reply property. I can test this out right here in the preview by creating a prompt like, "What are the colors of the rainbow?" And then tapping on the answer button, we see the response in the text view below the button. So let's clear the reply each time we tap the button and do this again with a couple of prompts. So we'll use the first one the same. What are the colors of the rainbow? Notice the response is different this time. How about a more complex prompt like, "What attractions should I visit in Vancouver, BC?" This is the city where I live in British Columbia, Canada. This time the response takes considerably longer. So in an upcoming video, I'll show you how you can let your users know when the response is being generated. Eventually, though, you'll get a lengthy response. And I have to say it's pretty accurate using some Markdown for formatting. Also in the next video, I'll show you how you can fix this up to make it more readable. Let me now just enter a word prompt like guns and see what happens. Now, for some reason, the preview is crashing, and I'm not sure why. So I'm going to run this on a simulator and see what happens. So it's just an iPhone 16 Pro simulator that I'll run. In the simulator, when I enter that single prompt, I get this very lengthy response about how Apple Intelligence will not assist you with that word. Well, let me ask it with more detail like, how do I make a gun? Now, to be clear, I never want to make a gun. I'm just using this as an example of how Apple Intelligence deals with sensitive topics. This time, I get no response at all. But the console is showing that a safety guardrail was triggered. That might be good information to provide as feedback to the user. So what we can do is we can simply change our try to use a do catch block. And then in the catch block, we can use the error's localized description and apply that as the reply. So let me run this again in the simulator and ask that same question. I get a rather cryptic but simple response. But it is better than no response at all. Now, if I want to provide more information to the user, we can dig deeper into the error and catch the specific error type and provide a more detailed response. And the error type is a language model session generation error. And then we can use a switch statement to catch all of the different error cases where you can get the context of the error. And the context has a debug description property that we could use. Now, I'm not necessarily interested in fleshing out all of these error cases, as I'm going to create a default case here that's going to catch those that I don't want to be specific about. So we'll create that default case, and in that case, we'll just let the reply be other error, and then use our error's localized description. So what about these other cases? Well, I'm just going to remove these first two cases here. For the guardrail violation, though, I will be using the context to set the reply to be a guardrail violation, and then provide as well the context debug description. So let me copy that. I'm also going to delete the next two cases, but you can do whatever you want. You can create your own custom responses if you want to keep these. For the decoding error, I'm just going to use that same reply and change it accordingly. And I'm going to do the same thing for rate limit. And I'm just going to remove the last two cases so that we're all covered. There is more though. It may be that the response could also produce a failure reason and a recovery suggestion, and these are optional. So we can check for those and append them to our reply. So I'm going to use an if-let to check to see if the failure reason exists. And then I'm going to use a plus equal to add to the existing reply. And I'm going to make sure that I add a new line first so that it'll be below the original reply. And I'm going to do exactly the same for the recovery suggestion. So let me run this one more time in the simulator, and I'm going to ask the same question about making a gun. This time I get the guardrail violation error, the failure reason, and the recovery suggestion. Nice. Now if I change that question to how do I make bread, that should be okay. It does take a while to generate the response, but eventually what I get is pretty good. And again with the markdown formatting that I'm going to show you how to fix up in the next video. Back at the beginning, I mentioned that you have to be on an Apple Silicon device running macOS 26 or later on a Mac, or if you're using an iPhone, it has to be an iPhone 15 Pro or later running iOS 26 or later. Now, if someone installs an app on a device that doesn't meet these requirements, you should show them an error message that says something. So let's check the requirements and show an error message if they are not met. Let's start by creating a state property in this view called not available reason, and we'll set it to an empty string. And this is going to hold the reason why Apple Intelligence is not available. So we'll need to first import foundation models. And then in the VStack, we'll replace the text view with an if-else clause. If the notification available reason is empty, this means that Apple Intelligence is available. So we can just show our UI. So I'm just going to add a text view with the text Apple Intelligence is enabled. In the else clause, though, I'm going to present a content unavailable view using the label and description initializer. For the label, I'm going to use a title string that would be Apple Intelligence is unavailable. And for the system image, I'm going to use a new SF symbol, Apple.intelligence. And for the description, I'll just use a text view with the text displaying the not available reason. So we'll need a function that can check to see if it is available. So I'll create the function called checkIsAvailable. And here you can switch based on the static default system language model properties availability property. And there are two cases, either available or unavailable. So if it's available, then we can just make sure that we set the not available reason back to an empty string in case it wasn't before. In the case that it's unavailable, though, we also get a reason, and there are 3 different cases for that reason. The first case is the Apple Intelligence not enabled. And if that's the case, we can set the not available reason to a string like enable Apple Intelligence in system settings. You're telling the user to enable the Apple Intelligence because it must be available on their device. But the next case for unavailable is the device not eligible, meaning it's not an iPhone 15 Pro or later. So in this case, we can set the not available reason to the string Apple Intelligence is not available on this device. And then the third case of unavailable is when the model itself isn't ready. And you'll see that shortly. And we can set the not available reason to the string that the model is not ready. And then we can use a new line and specify that it's downloading or temporarily available. And then another new line, and then the string, please ensure that you have sufficient battery and Wi-Fi. And then to cover all other possibilities, you can use the case of unavailable with an unknown variable. And then you can then assign the not available reason to be the string foundation models is unavailable, and use the string describing the unknown reason as a interpolated value of the string. So now when this view appears, we can call this check is available function. Now in order to do this check, I'm going to have to run it on real devices. And I've got 2 iPhones. One is an iPhone 16 Pro running iOS 26, and the other is an iPhone 11 running iOS 26. So first, my iPhone 16 Pro. Now when it launches, I can go to the second tab, and I see that Apple Intelligence is indeed enabled. So let me switch over to the Settings app, though, and turn off Apple Intelligence. When I return to the app, it's still saying that Apple Intelligence is enabled because it's not calling that check is available function, and I'll fix that later. I can, however, go to another tab and then back again to trigger that on appear block that's going to call the function, and it calls the check is available function. And now I can see that Apple Intelligence is unavailable, and the reason. I need to go and turn it back on. So let me go back and turn it back on. And I come back and do the same thing. I'll go to another tab and then back to the second one. This time I see that Apple Intelligence is unavailable, but the reason is that it's taking time to download it again. So I'm going to have to wait for that, and eventually it will be available. So what I'm going to do is I'm going to return to our content unavailable view, and I'm going to add an action. And for the action, I'm going to create a button with the title Try Again. And the action will be to call the check is available function. And I'm going to make that button style bordered prominent. So let me run once more. I can see that it's now enabled. So let me go back to the settings and disable it. When I return to the view, I can see it's now disabled with that Try Again button showing. And tapping it here would do no good here. So let me then go back again to the settings and turn Apple Intelligence on once more. When I return once more, we see that we're told the model this time is temporarily unavailable. So I can keep tapping this button And eventually, when it does become available, the view changes to show our content. So let me just quickly now switch to my iPhone 11 Pro that is running iOS 26, but it doesn't have Apple Intelligence capabilities. When I launch the app, I'll go to the second tab, and I see that it is exactly what the content unavailable view is telling me. Now, since it would be good practice to have this part of my toolbox going forward, I want to make this easily insertable into my projects. So I'm going to make a foundation model service that I can inject into the environment and call that function from anywhere and anytime that I need to check it. And I can also in future do other things in that service, as you'll see in the next video. So let's copy that function to our clipboard. And I'm going to create a new file that I'm going to call Foundation Model Service. I'm going to import foundation models. And then I'm going to create an observable class of the same name. So I'm going to have our not available reason here as an observed property. But I'm going to set the default string, instead of being empty, to checking for model availability. And then to make it easier to deal with, I'm going to create a Boolean computed property called isModelAvailable. That will depend on whether or not the not available property is empty. And then I can just paste in my copied function. Now, when I create an instance of this class, I will have to check for availability right away by calling the checkModelAvailability function in the initializer. Now, since we want this to be determined right at the time the app launches, we can go to the starting file and create an instance there to initialize it. And I'm going to call it FM service. And I'll inject it into the environment. Now let's take a look at the third tab, which is the observable isModelAvailable view. Here, I can get access to the instance from the environment using foundation models service.self, and I'll call it FM service here too. Then to make the preview stop complaining, I'll need to inject another instance here into the previews environment. So let's go back to the previous tab and copy that content unavailable view from here. And I'm going to use it for its own independent view. So I'm going to create a new file called AI unavailable view. Then I'll replace the text view with what's on my clipboard. So I'll need to get access to the FM service from the environment, just as we did in our third tab. And I'll have to do the same thing to inject the instance into the preview. For the description then, the text is just going to be displaying the not available reason from that FM service. And the button will call the checkIsAvailable function from the FM service instance too. So back in the third tab, we can now replace the text view in the VStack. And since we have access to the service, we can check if the FM service isModelAvailable computed property is true. If it is, we can carry on and display whatever content that we want to. Else, we're going to present the AI unavailable view. There's one more thing though. Remember when we came back to our phone from turning off Apple Intelligence, we had to go to another tab and then back again to force the function to be called? Well, we can do that by checking the environment's scene phase key path. So I'm going to create a new environment variable called scene phase. And then we can observe that key path changes within an onChange block. Now, I don't care what the old phase was, just the new one. And if that new phase is now equal to the active case, we'll just call the FM service check is available function here. So let me run this on my iPhone 16 Pro now. And I want to go to the third tab when launched. So Apple Intelligence must be available as I can see my text view. So let me go back to the settings here and turn it off. When I return to my app, I see that the scene phase, notice the change to active, and the function was called, and now it's displaying the content unavailable view. So let's go back to the settings and turn it on. When I return back to my app, it's called again, but this time it tells me that it's still unavailable, but the reason is different. It's loading the model, and it's going to take a while for it to load and be available, but I can keep on checking until eventually I'm good to go. So that's it for this tutorial. We've covered a lot of ground, but what you've learned is essential to building an app with Apple Intelligence. And we'll be using a lot of this code in the next set of videos, including this catch block. So I'm going to copy this and use this in future videos. And I can reuse this observable service class. That's going to come in handy. And the same thing with the content unavailable view. So in future videos, I'm not going to retype in that code. I'm going to provide it in the starter projects. So I hope you stay with me for the next set of videos. It gets really exciting after this point. If you found this video helpful, please like and subscribe to my channel. It really helps. And remember, you can get access to my videos by downloading my free channel listing app for the Mac, or you can use the web version on an iPhone or an iPad to get better searching and viewing of my content. Links are in the description.